Hello, this is Pete Cachopi. I'm Chief Scientist at Oppolytics, and today's presentation is about debugging and troubleshooting solver engine code in Python. So this is a companion presentation to the more Oppolytics specific, or I should say maybe the more mixed integer programming specific presentation about using TICDAT to build modular modular mixed integer programming engines. So again, as a review, TICDAT is an open source data science library. It's a relatively thin library published by Oppolytics. TICDAT serves two purposes. It helps you build solve engines that are standalone. TICDAT has a lot of built-in file I/O, so you can build a solve engine that just focuses on math and leave the file I/O to TICDAT. And almost as a two birds with one stone, it also facilitates building solve engines that can be deployed on the Oppolytics cloud platform and can have and can thus be given slick GUIs and all kinds of advanced reporting tricks and graphics and great stuff like that. So this presentation isn't about that goal. It's not about the goal of building solve engines specifically. It's about just troubleshooting issues. So this is a more generic Python related presentation, and this is in response to feedback I've gotten and also to my experience coming to Python, in that if you're a sophisticated mathematical person, you're a sophisticated data science person, you have familiarity with data munging in some older tools like Excel and Access, you have familiarity in building models with some older languages like AMPL or OPAL or GAMS, and you're coming into Python, what's relatively easy is learning Python, the language itself, because Python has a huge online resource community. So there's lots of free courses. Python itself, it's very easy to get going with sort of interactive programming with Python, where you can conduct little experiments to learn Python. And it's very easy to ask questions or to use Google to find questions that have already been asked or answered on the online forums. And this is just one of the main benefits of Python, and why Python is arguably revolutionizing the data science world, is because the internet, it's both a well thought out, logically consistent language, and it's also a language that has a huge resource base. So there's a lot of great tools out there, and there's a lot of great learning resources. What seemed to be a little bit lacking is going through, there seemed to be sort of perhaps arguably a shortage of videos where you just walk through the nuts and bolts of okay, I've got my engine more or less coded up. I want to run it on some data and it's having problems. How do I debug those problems? There isn't, if you read the Python literature, there doesn't seem to be any one consistent integrated development environment that makes sense for Python, or that everyone has agreed to for Python. There are definitely people who do development with integrated development environments for Python. And if you want to be one of those people, then there's other resources out there for you. The focus of this video is using relatively standard Python. So using the two tools I focus on are IPython, which is sort of an enhanced Python interpreter, and also IPDB, which is a Python package that implements debugging that's consistent with IPython. And I like using those tools for debugging so that I'm not dependent on any one integrated development environment. That makes it easier for me to debug on other operating systems, or to screen share with people and debug my code, or help other people debug their code, regardless as to what particular toolings they have. So in order to, if you want to follow through with the steps I'm doing here, the example code that I'm using is right here online. This is a public repository under the BSD license. It's the example NetFlow. This is an example you can find. We're using this example. We sort of extended this example with permission from Gurobi, although these same basic tricks would work just fine with Cplex. And I've created a troubleshooting demo branch of the example NetFlow repository that has some bugs in there, and so that way I can walk through the fixing of the bugs. So let me, and I've got that repository cloned on my computer. So if I go to my source code and type git status, then I'm on troubleshooting demo. So let's go back to my Scratch directory. And you can see I'm not working in my source code directory, I'm working in my Scratch directory. I feel safer doing it this way. There's a few things that I do that fall under the rubric of only the paranoid survive, and you don't necessarily have to feel obligated to share my paranoia about these things. There are other areas where I'll highlight it a bit more and say this is a little bit stronger than only the paranoid survive. This is more falling under the rubric of we're all adults here. So there's certain precautions you should take that you really have to take in order to be a mature Python programmer. And there are certain precautions that I take because I'm a mentally healthier person if I exhibit a certain amount of paranoia in terms of trying to make my code as reproducible as possible and not to make sure my code doesn't trick me into having me think it's working when it's not really working. So again, the point is I've got this repository here cloned on the troubleshooting demo. So now what happened? So if you want to deep dive into this repository, there is the NetFlow example and there's the diet example, and I have other presentations that deep dive into those two. So I'm going to presume that you basically know what's going on with this repository and keep driving. So if you look here, I added some bugs. Here are the 3 bugs I added. So a member function is being called with the wrong name. The wrong numerical piece of data is being checked with a self-assert true statement, and a data field is being populated with the INF string instead of the float infinity. So this is a typo, this is a typo, this is the sort of thing that would happen if you cut and pasted and forgot to edit the data. And I'm going to deep dive into if you're not familiar with what self-assert true means, then this is the right presentation to you because we're going to deep dive into that as part of our little tour here. So I talked about IPython and IPDB. So again, IPython is a supercharged Python interpreter. It comes with Anaconda, so if we encourage you to use Anaconda. If you have Anaconda, you should be able to go to your equivalent of this command line prompt, type IPython, and launch the IPython program. So again, I'm doing text-based, command-driven editing. This is not, or command-driven debugging. This is not what you see is what you get. If you want to do what you see is what you get debugging, there are other tools out there for you. I like doing it this way. I think it's faster and it's more portable. But there is a bit of a learning curve, hence this presentation. And then the other piece we need is IPDB. So none of this is going to work unless you have IPDB on your system. So I do have IPD on my system. If this had failed, if this statement in IPython had thrown an exception, then you could just quit back into your command script, your command shell, and type pip install IPDB. But I'm not going to do that because I did that earlier. I have IPDB installed here. So, okay, let's dive in. So what do you do and I'm also using PyCharm here as a text editor. Bear in mind that PyCharm has some IDE functionality built in. I don't use that part of PyCharm. That way I'm good to go if something happens to my PyCharm. All I really need is a text editor that has the line numbers. The line numbers, if you don't have the line numbers showing up in your text editor, you're not going to be very efficient with Python. So let me just double check. Sure enough, here's one of those bugs that I talked about. Here's one of those bugs I talked about. So I'm working on the right branch. So what we're going to do is we're going to launch this file here. So inside of the example NetFlow repository, inside the NetFlow directory, which implements the NetFlow package, inside the testing subdirectory, which is not a public part of the NetFlow package. It's the testing part. I like to put my testing, nest my testing inside the package so that it's easier to get a hold of it. It's still obvious that it's testing because you can't get to this section without saying .testing. So there's still we're all adults here. Decorum is being obeyed. You're not going to accidentally wander in there. You're going to be deliberate if you're using the testing. And then inside the testing directory, we have this test NetFlow script. This script finds this simple data SQL file, runs it, validates some value, changes, then it makes a copy of that data again, changes a specific value, a specific data cell to be larger. As a result, the solution is supposed to change, and I have a bug in my testing here in that I'm looking for the solution value to be the same when in fact it's supposed to change. Then it copies the data again, and it makes some args infinity. I have a bug here in that I'm not populating infinity correctly. And in this case, everything is supposed to be the same because this constraint is loose even in the original data set. So this line here where this is a line that I deep dive into a little bit in the other presentation. This reads the data set into a dat object, into a dat variable. This is a tickdat object. This is sort of the tickdat equivalent of saying, find this data file and read it consistent with this schema. Read it consistent with this schema and make me an access database from that data file. So you can think of dat as being sort of like an access database that you know is roughly consistent with the schema defined in Data Factory. And if that bit of it confuses you a little bit, again, there's another presentation, and also I think some of this will seep in with osmosis. The data file here, this subroutine is smart enough to know where this directory is, so it's smart enough to find this data file, which is just a data file written in SQLite. It doesn't need the schema definition because the schema is built into tickdat. It's one of the handy things you get about tickdat. This data file was created automatically. I didn't have to populate it manually. I had an Excel file with the data, and I was able to just in one line of in IPython, I was able to create this .sql file. So now let's run this testing script. So the easiest way to run a test, your unit test testing script is to just launch it with Python. And if you have tab completion, then finding the path is easy. So there I am launching it. And here's one of the errors I talked about. So this right here is gives me a clue in the file system where the problem is happening. This is what's happening here is there's an unhandled exception. So there's an exception being thrown. None of the code is catching the exception, and so the exception bubbles all the way up to the top, and it's unhandled. And the unit test framework is giving me a sensible error message regarding the unhandled exception. It's telling me the history of how we got to the unhandled exception. So first, in test net flow, we called tests. In test net flow, we called solve, and that's at line 33. So let's jump over there. Line 33. Yep, we're calling solve. The first time we're calling solve. And then line 61 in netflow.model.py. Line 61. Okay, the problem is right here at this line. So I know I'm going a little fast there, but the idea is that you should develop skills if you want to be, serious about Python. This is part of the learning curve. Part of the learning curve is not being overly intimidated by one of these tracebacks, and instead just keeping your cool, looking at the file number, looking at the line, and walking it through and seeing if you can gain some insight. So right now, I'm just going to assume that just by staring at it, I have an aha moment. I see the problem is line 61. I see there's a sort of similar call being made here at line 75. And I'm going to take a stab at saying, okay, maybe this is the right name and not that. So I'm going to copy that name up here and see if that works. Now I'm going to deep dive into this, fixing this bug even more. I'm going to beat this dead horse even harder at the very end of the presentation. But for right now, I want to fix this bug in the simplest way possible to sort of get our sea legs a little bit. And then I'm going to come back and do the most sophisticated piece of debugging that I do using my IPython and IPDB tricks. And I'll put that most sophisticated piece at the end. But the simplest way to debug is if you know specifically the line that has the problem, and then you stare at it and the insight comes to you. So let's just assume insight came to us, and we tried to run the test again, and sure enough, it must have worked because now we're hitting a different problem. So now so before we had this problem here at line 33, and now we're having a problem at line 39. So it must be the case that we're working our way through this test. So I probably should have showed you this earlier, but let me just step back a little bit and review. This is how the unit test framework works. This is the way the way we recommend you build your archive testing for your engines is that you use the unit test framework. So unit test is also a package that you need to have installed, similar to IPDB. Once you have that package called, you can build a class that derives some unit test test case, and then you can use this standard Python trick to call unit test main when this script is used as a base script, as a launch script, as opposed to a library. When this unit test main launches, it knows enough to find this test netflow class, and then it walks through the testing class and finds every function that starts with test. And it launches every function that starts with test and gives you intelligent messages when problems happen. The two types of problems are the one we saw a minute ago, the unhandled exception. It gives you a good diagnostic message when an unhandled exception occurs. Or this problem right here, if you have lines like self-assert true, where the argument to self-assert true is false. So this assert true code is a member function of the unit test case class that you're deriving from. And what assert true does is it evaluates its argument, and if its argument's true, then it just walks on happily, and if its argument is false, then it gives you a sensible error message and stops executing. So, or it stops executing this test. It might go on to some other testing test in the same class. So, and so those are the two types of problems we're going to investigate. We already saw the unhandled exception, and we're going to deep dive into that at the end. And now we're seeing the assertion error. This is in a self-assert true. This manifests differently than this. So don't be too fooled by the word assert. This one will manifest with this sort of error message, like false is not true. And this one, if one of these fires, so if the second half of the assert keyword statement is false, then an assertion error will be thrown. And that's like an unhandled exception. So you'll get the hang of it as you watch me go through this. So again, so now there's some sort of problem here. So let's assume the method of staring isn't working, and let's assume what I want to do is to somehow be able to jump into the code right at this point and examine the data. So how do I do that? So this is where I point you at these two utility functions that I've made available for you in the TICDAT library. So this is in the testing section. So I want to emphasize enough that you should only use the testing section in your test code. So don't use anything like TICDAT.testing in something like this NetFlow model, because this is the code that's actually supposed to run when your users run your engines. But in your testing code, the rules are a little more relaxed, because the goal with testing code is to execute testing. And I'm supporting these two functions as being utility functions that you might want to use if you want to debug the way I debug. So the standard ready for debug setup that I use is I have a line like this that imports my utilities, but the line is grayed out here in PyCharm because it's not being used, which makes sense because the way my tests are normally set up to run and give good diagnostic messages, they're set up to be the normal way. And then if I want to debug them, I edit the code very slightly to go into sort of a debug mode. And the way I go into a debug mode is I make sure that the fail to debugger decorator function is decorating my testing class. So if you don't know what decorators are, there's a lot of good online resources about the Python language that will describe decorators. What this decorator is doing is it's changing the behavior of this NetFlow class, and it's a little bit of an advanced decorator. Then it's also changing this unit test, the unit test module itself, unit test package itself, so that the unit test main will behave differently and facilitate jumping into the IPDB debugger to look around at things, and also facilitate looking at things inside IPython. So you should not have this code enabled when you're doing your check-ins. What you should do is just turn this code on as a temporary measure to go into debugging and then clean it up when you're all done. So I'll walk through that workflow. So I've uncommented it. So now the decorator is applying, the fail to debugger decorator is applying to the class. And now I'm going to launch it. I'm going to launch my test not from within the command shell, but from within IPython. So this is the way you do that. First you go into IPython, and then you run this file path instead of you type in exactly this same line here, except Python instead of run. So let's do that, and I'm going to show out how great the tab completion is in IPDB, so I don't have to memorize the path. I don't have to cut and paste it, although I do like cutting and pasting. I can just tab complete. This is not me typing fast. This is IPython being awesome. So, all right, and what happened? I jumped from an IPython prompt to an IPDB prompt. I'm inside of IPDB. So IPDB, again, has lots of great resources online. You want to familiarize yourself with the basic IPDB commands. I'm going to assume that you've put a little effort outside of this video into watching IPDB, or you're going to do so when this video is done, and I'm not going to give you an IPDB tutorial per se. I'm just going to let you watch me debug with IPDB. So this is so the first thing I do is I look at my call stack, see the history of how did I get here. And this is sort of similar to the trace back before. You don't really need to watch the whole thing. You say, oh, okay, here I am at line 39. That makes sense. And then line 39, it tried to call an assert true, and then something funny happened that put me 2 steps deep inside of this line in tic-tac testing. That's what happens when that's the way that the fail to debugger does its job. It's thrown me into the IPDB debugger, not exactly here, but it's put me into the IP debugger in a place where it's easy for me to get here, and which is where I want to be, where I want to examine things. So all I have to do from here is type in U twice to walk up the call stack. And again, I encourage you to study IPDB a little bit so you know what all the commands are. There's not that many to learn. I think I regularly do, I think I almost always just do like 4 commands and I can do all my debugging. So there was a problem with this assert true. So let's do some cutting and pasting. Evaluate this argument. Okay, sure enough, it's false. Okay, so my sanity is assured. Let's evaluate sub pieces of it. So this is where I'm being numerically sophisticated here. I'm not trying to say that instead of checking that this equals 30, I'm checking that this data cell has a % error that's very small, right? And just what is this exactly? So let me do a quick, I talked about this in the other presentation, but let's do a quick summary. This is the equivalent of an access database that corresponds to a solution that was created. This is the equivalent of a table in an access database. This is the equivalent of a row in a table in an access database. And this is the equivalent of a cell in a row in a table in an access database. And this is all if you're using the native tic-tac techniques for dealing with a table. You could also do work like this with pandas. Frankly, I find the dict of dicts approach that tic-tac uses to be handier than pandas for a lot of my work, but I also jump into pandas occasionally. So again, so this is the % error is big, so it's not some funny numerical rounding thing where I'm just a little bit more than expected off. I'm off by a lot. So let's look at that exact data cell. I'm expecting 30. It turns out to be 20. Let's list the code, right? And I say, oh, okay, I see what happened. I copied the data. I jacked up the cost for this particular arc. And then, oh, this particular arc used to be 30. And then now I'm checking that it's 30 again. Okay, that doesn't make any sense. I'm supposed to be checking that it's a much smaller number. The idea behind jacking up the cost was I was forcing the solver to to create an optimal solution that has a much smaller number for this arc. So I'll go back and fix the bug, put 20 in there instead of 30. So again, this is, all right, so earlier when I talked about only the paranoid survive, or the fact that I err a little bit on the side of paranoia, one of the ways I err on the side of paranoia is that whenever I fix a bug, I double quit and restart IPython. So there's a way from here in IPython to sort of clean IPython, but I don't see the point of that. Just quit, restart it. This way, I'm more confident that it's truly clean this way. And then I can use up arrow, and here I am. I'm running the same test, except it's different now because I've changed this. I fixed this bug, so now I'm on to the next bug. And so now we have a different problem that occurs. We have an assertion error. This, again, what I hinted at this before. This is an unhandled exception. This is it's not the same thing as the assert true that drops me straight into IPDB. In this case, an unhandled exception occurs and I'm back in IPython. So you might say, geez, this isn't that helpful. How can I examine things? I need to be in IPDB to examine things. This is where this super powerful IPython command comes in handy. This is magic debug. Magic debug rolls back in time to right before the unhandled exception occurs. So I go back to, if only you had this in real life. Let's go back to right before this big mess up happened and examine the way the world was right before the mistake happened. So if you're familiar with the other presentation that goes into TICDAT and modular solve engines, you'll recall that our goal for building solve engines is that they're self-documenting and self-validating. So by self-documenting, I mean we define the input and output schemas, which is another way of saying, okay, logically what we're doing is taking something that's just like an Access database, and we're not going to work on that Access database until we validate the Access database obeys certain rules. So it should have expected table names, expected field names. So that's what all of this code here, it defines the expected table names, the expected field names, the way the primary keys relate to each other with foreign keys, and also the legal rules for what type of data is allowed are all defined here. This is self-documenting, so you don't need a long comment as to what the rules are. This code defines the rules for you. Here it's self-validating, where I enforce those rules on the input data. So again, DAT is like an Access database. First thing I make sure is I validate that it has good table and field names. That's the most high-level sanity check. Then I check to make sure that the foreign keys all link up with each other. And then I check to make sure that the data cells all have good values. And this is the mistake that's failing here at line 44. So what's happening here is that if you know a little Python, you know what I'm talking about with words truthy and falsy. Truthy is something that evaluates to true. Falsy is something that evaluates to false. By convention, containers that have things in them are truthy and empty containers are falsy. What find data type failures does is it looks for all the data type failures and it puts all the data type failures in a dictionary. So if there are no data type failures, then it's an empty dictionary, which is falsy, and then that becomes Boolean true and the assert passes. But the reverse must be happening. So it must be the case that this is a non-empty dictionary that describes some data type failures. So let's evaluate that in IPDB. And sure enough, here's a dictionary. It says for the args and for the capacity field in the args table, I encountered this INF string, which I recognize as a bad value, and I encountered it for all of these rows, and it gives you the primary keys for all the rows that had this specific problem. So this is the list of primary keys. And if you're familiar with this data set, you'll know that these are all the primary keys. These are all the rows. So essentially what it's telling you is all the rows have this specific problem of a INF string in there. And so again, one of the handiest things in IPDB is to walk up the call stack. That usually helps jog your memory. And then, let me list a little bit here. I see what's happening. I'm copying the data to make a fresh data copy. Then I'm editing that fresh data copy, and I'm putting in this INF string, but that's not numeric. And when I built the data rules over here, this data rule insists that it be numeric, and it's a non-negative numeric that can include the float infinity. So it's an inclusive max, and the max is the float infinity. So that obviously is what I was trying to put in there when I typoed. I was trying to put in the float infinity here at line 43, which again, I can go back and match up at line, that's also listed as 43 here. So I ran into troubles at line 44 right after I did this silly thing at line 43. So let's fix that silly thing. Put a float in there. Okay, and then again, only the paranoid survive. So I'll double quit, launch IPython again, launch my test again, up arrow makes life easy. And look, it didn't, there was no exception thrown. I didn't jump into IPDB. I got this ending message. This is the message that the fail to debugger decorated class gives you when it's done testing and nothing untowards happens. So there was no problems. If there's no problems, then the text output gets sandwiched between a line that says debugging, start line that says debugging, and an end line that says debugged. And if I was all done here, so now that it looks kosher, then always the last thing I do is I return it to its natural state. So now it's no longer, this code is no longer in debug mode because this failed to debugger decorator isn't applied. So this line is now completely grayed out because it's not being used. So I'm in normal mode, and I run the test from the command shell, and this is what the messaging looks like. So at this point, I would check in my code and saying it's good, right? This is the diagnostic message you get back when everything works correctly. You get this okay. You get a diagnostic line that says the number of tests, and I know it is one test because I know I'm just supposed to be running this one function. So I'm not going to quite end up here because you could stop if your brain is filled. This is a good spot to take a break, but I'm going to keep going and show you one more thing. I'm going to show you this memo line, so this memo function. So the two functions, again, I'm making available to you for emergency debugging are fail to debugger and memo. So let me show you what memo does. So in order to do that, let me go back, put this bug back in. Oops. So I'm putting the bug back in, calling the wrong function name. I'm going back into troubleshooting mode, debugging mode. I'm going back into launch IPython, launch the test from IPython. This is the standard debugging mode. If you have problems, you go into debugging mode. Again, debugging mode means I apply the decorator, I launch IPython, I run the unit test script from within IPython. Okay, and then now I've got the unknown. This is similar to the assertion error before. I'm back in IPython, and it says there was an unhandled. This is what you get when there's an unhandled exception. In this case, the unhandled exception was a Gurobi attribute error, unknown attribute error. So what do you do from here? Again, magic debugger. Okay, and this code is not my code, so I'm going to go up the call stack till I get to my code. So my problem was here with this line of add cons. So let's assume I was having trouble, it wasn't obvious to me what the right line is here. What the right function to call is. So I want to play around and see if I can deduce what the right call is. So this is in true Python style. I'm going to kind of explore from IPython instead of reading the documentation somewhere else. So if you're like me, you'd much rather explore the documentation than have to memorize it all in one go. So what is the M object here? M is a Gurobi model, makes sense. Let's get a list of all the attributes for the Gurobi model and see if we can find the one that looks right from that list. Okay, this is not very readable. This is a little bit of the downside of being an IPDB, is that when you evaluate things, they don't render as nicely. So what I like to do is, what I can do with memo is that I can use memo to remember this variable and then see it within IPython. So how do I do that? Well, first I call memo, call memo with mem as the argument. Whoops, it didn't work. Okay, that's fine. I did that deliberately. If you try to call memo and it doesn't work, then you can just cut and paste this line. You don't really need the fail to debugger section, but there's no harm in using it. You can cut and paste that line into IPDB, and then now try memo again, and it works. It didn't make a mistake. So what memo does is it remembers and recalls. So memo has now remembered the M variable, and it's returned to me the thing that it had recalled previously. In this case, there was nothing that it had recalled previously, so it returns to me the empty list. So, but I'm going to have some faith that memo had remembered M, so I'm going to quit out of IPDB. Now I'm back in my everything is prettier here now that I'm in IPython. And now I'm going to make a new M variable inside IPDB that is the result of remembering what I memorized before. Oops, my mistake. I said M equals memo M. I don't have an M yet defined. I'm defining M. So I'm going to call M equals memo with no argument. It's fine to call. If all you want to do is recall but not memorize anything, you just call memo with no argument whatsoever. So that worked. So there's M. Now I have defined M, the same as before. So now I can call dir M. And now I get a much more readable list. So in theory, it's going to be easier for me to find add const by scrolling through this nicely sorted list. But hey, let's go a little bit farther and work a little Python here because we're Python people. Let's say x for x in dir m if add cons in x dot lower. So if you're not familiar with this statement's doing, again, this is just reviewing some Python stuff that you could learn. You could learn elsewhere, or you could learn by watching me. It's fine. So all I'm doing is I'm doing a list comprehension of all the attribute names for this Gurobi model if the add cons is a case-insensitive substring of that attribute name. Now I've got two choices. And of these two, which one is it likely to be? Okay, it's definitely not this because this starts with an underscore. Remember, we're all adults here. This is not a paranoia thing. This is just good adult behavior, is that I don't call functions that start with an underscore. So the underscore functions are private, right? So this is what obviously the Gurobi engineers want me to use. So let's make sure. Let's look at the help. Remember, this is what I promised you. You could look at the help at the documentation for the Gurobi documentation right here within IPython. So no need to go look it up in Google. It's right there. I typed help m add const and it gave me the help. And it says, add a constraint to the model. So this is definitely the one I want to use. Oops. So I quit out of IPython. And I go back here. And it was line 61, so I fixed it. Oops. And then I can, again, this is the way I finish up my debugging. As I run it from within IPython, I get a clean message. And then I make sure to clean up my testing code, go back to normal mode, and then I run it from the command shell itself. This is always the way I end things. Run it from the command shell, get the OK, validate that it's the right number of tests. So thanks for your patience here. I hope this helps you. Again, there's lots of ways to debug in Python. This is the way that I like to debug. I like to do it this way because I only need a minimal amount of tooling. All I need is a text editor that has line numbers, IPython, which comes with Anaconda, and IPDB, which is easy to install. And these utility functions, which are there for you in TICDAT, or you can look at the TICDAT source and create your own flavor of those utility functions. So thanks for your time. Feel free to drop me a note, and I hope you enjoyed it.